Hello and assalamu alaikum. My name is Fakisha, and today we will be implementing Demux in Quartus by using Verilog HDL program. So we will be using many different techniques to implement Demux circuit, and we will see its waveforms. So first of all, we will see what's a Demux. So here in front of you is a Demux. So it has a single input from uh, the input source and two conditional inputs, so control inputs which we say, and it has four outputs. So it can give four out different kinds of output, 4-bit output, and has a single bit input. So first of all we will do gate level implementation. So I will paste my code over here. So here in front of you is a gate level implementation of a Dmux. So it's a module I've given given it name of mine. It is Faki, and then it has input, this single input, and two control inputs, and these are y1, y2, y3, and y4 are the outputs. So here we have written the output. It's the output, four output we have, and these are three inputs, and we are using two NOT wires, and we will also having two the control wires. So here we have a NOT gate connected to the NOT control wires and NOT control wire 1. So it will be the output of NOT gate, and this control 1 will be the input of NOT gate, as you can see in this picture. So this is the input, control 1 is the input to the NOT gate, and output is the NOT control 1. So similarly, the control 2 input and output are working. This AND gate is attached to the input is output is sorry the output is y1, and the input is in one, and not control 1 and not control 2, and similarly, and the other AND gates, other four AND gates are working. So I will simulate it. So after our code has been compiled, we will see its block diagram from RTL viewer. It's a circuit diagram of our Demux for 1 to 4 Demux. So this is one single input, and these are two control inputs. So these are the four outputs. Um, Here I have made the waveform for it. So you can see for first clock I have provided 50, and for this 100 and this 200, when it's with 0 0 1, the y1 is working, and when its control input is 1 and second one is 0 and the input signal is 1, or y3 is working. So similar in this way, or all the gates are working in a rhythmic manner. So now we will move toward the second implementation. So the next type of implementation we are doing is case statement implementation. In this we are using case statement over here, and in case statement we have control 1 and control 2 are being used by this case statement, and when these are 0 0, when both are inputs, what means this control 1 and control 2 is 0, this in is going to y1. If control 1 is 0 and control 2 is 1, this in is going to they are all going to activate this y2 output, will be 1 and means high, and if control 1 will be high and control 2 will be low, so this y3 is going in is going to y3, and this y3 will be giving us high output, and similarly this y4 is working when both control 1 and control 2 are high. So let's simulate this. So here, after our code has been compiled, you can see over here as it is compiled. So this is a input going to all these latches, we store the actual input. So, and this is a decoder attached to these control inputs. So it's working like that. If I show you the waveform over here, so here when the input is coming, it stores over here y1 and it passes like that. Similarly for y2, it's working when control 2 is also on, and control y3 is working when control 1 and in is on. So it's working like that. So now we will move on to our next implementation. So here in the next type of implementation, we are using if conditions. So in the same way, we are using select over here. We are using the inputs. We are using the three outputs. So in this condition, the if statement begins from if from begin. It's begin letter word and ends at the end word. And in between, we have four if conditions and. This implies that if select that both the controls are inputs are zero, they are and the inputs is the first one is the first output and input is high, so it gives the first output. So we will see over here the how the block diagram is. So here we have all the same way in the previous we had latches, so we are also having latches over here. So they help us to store the signal, like if I show the waveform. So over here we are giving the input signal with 50 hertz and 50 clock. So we are giving this select input, that is 00011011. So you can see when this is 00 or this first gate is working, and when we are giving 01 on of the control, or second we are getting or second output, and in 10 we are getting the third output, and 11 we are getting fourth output, and the same way it's repeating, and we are getting the same input as the of the input signal of clock in the first one. We are seeing that these are same cycles of repetitions. When it's high. When the in is low, it's low. So in this way it's working. Now we will move on to our next implementation. So in this type of implementation, the condition type of implementation, we are using conditions over here. You can see the question mark we're using is our equal signs. So we are using condition, and these are sign statements we're using over here. So there are two inputs. There are select inputs, the control inputs, and we have two. We have this other input, that is the actual input, and this is that are four outputs. So we are using like Q0, Q1, that are like we used to do in arrays in C or C++. Okay, so this if the control that means select is 00, that is both the control inputs are 0. So this one it we will show the gate the output 1. If it's the 01, then the output second one, and likewise third one, fourth one. If we see the block diagram for this, so here it is. And these are the remarks used over here. So we can see from this waveform, as we are assigning this signal clock signal to the input, and then we are using this 00100111 to the control inputs. And so these are four output signal over here. So when both the control are 0 and input is also 0, then output is we are having over here is 0. But if both the inputs are 0 and the input signal is both the controls select are 0, and we have one on the, I mean high signal on the input, So it will have our first output will uh, from the first we will have the output signal 1 and all other will be 0. Similarly, when we have a high signal on the input and our select one is high and the other select is 0, so we have our uh, third input, third output we will having from the third output we will having okay, and similarly these gates will be implementing like that. So now we will move toward our next implementation. So here we have the logic state implementation. In this type of implementation, we have four outputs, and these are equal to this. Um, the inputs coming to the AND gates are in and not of control 1 and not of control 2, and these all give the output y1. And similarly, this y2 is the output of into AND gate, which is also has the not of control 1 not of and a simple control 2 input. So these are the basic statements. If I show you the block diagram over here, it has this control input which is going to all these AND gates, and we have two more AND gates actually over here. We can it could also make like three inputs to each AND gates, but it has given this two inputs to every AND gate and designed the gates like that. So if I show you the waveform of this, so here the waveform, um, if I'm giving the 0 to the input and 0 to the second control in, so nothing is happening. But if our control 1 is 1 and control 2 is 0, still nothing is happening because there is nothing high in the input. So when the high in the input is occurring over here and both the control 1 and control 2 are 0, so our y1 is high. And if our control in is high, input is high, and the control 2 is also high, and our control 1 is 0 on that case, so we have y2 as high output. And if our control 1 and control 1 is high and input is high, so we have y3 as high output. So this is working nicely. I think that was it from this video. Thank you very much.